In this second example, we are given a non-one-to-one function. This means the function does not have an inverse. Our task is to restrict the domain for this function, so that it will become a one-to-one function, and will then have an inverse. We start with the first function, fx equals to modulus of x minus 3. This is the sketching of the modulus function. By now you should already know how to sketch a modulus function. First, we want to show graphically that fx is not a one-to-one function, by using horizontal line test. The line y equals to k cuts the function at 2 points. This shows that fx is not a one-to-one function. Therefore this function does not have an inverse. The function will have an inverse if we change it into one-to-one function, by restricting its domain. The domains are, from 3 and including, to infinity, or from negative infinity to, and including 3. The first restricted domain is, from 3 and including, to infinity. The elements in this domain are from 3 and above. If we substitute the domain into the function, we will get positive values. So, we can eliminate the modulus. The function will become fx equal to x minus 3. Next we use the composite f of f inverse equals to x. To find the inverse, substitute the f inverse into the function. We will get f inverse of x minus 3 equals to x. Thus, f inverse of x is equals to x plus 3. The second restricted domain is from negative infinity to, and, including 3. The elements in the domain are less than or equal to 3. If we substitute the domain into the function, and eliminate the modulus, we will get negative value. So we get another function, fx equals to 3 minus x. Next, to find f of inverse x, we use the composite f of f inverse x equals to x. Substitute f inverse x into the function, we will get 3 minus f inverse x is equal to x. Thus, f inverse of x is equal to 3 minus x. Therefore fx and f inverse x are the same function. We say, the function is its own inverse. So, this is the original modulus function. We have split the modulus function into two linear functions according to the restricted domain. Then, we sketched the functions separately. We then sketch line y equals to x for both functions. Lastly we sketch the f inverse for both functions, by reflecting fx on the line y equals to x. Next, is question B, from the second example. This is a quadratic function. To determine whether this is a one-to-one function graphically, we have to sketch the function first. Apply horizontal line test. By sketching a horizontal line y equals to k, across the function, the line cuts the function at 2 points. Thus, fx is not a one-to-one function. Therefore, f inverse x does not exist. In order to make f inverse exist, the function must be a one-to-one function. To achieve this, the domain must be restricted to negative infinity to 1 and including, or from 1 and including to infinity. We have restricted the domain into two separate parts. Next, we are going to determine the inverses of the function. First of all, we have to use completing the square into completed square form of vertex form. To find f inverse, we find the composite f of f inverse x equals to x. Substitute f inverse x into the function. We will get f inverse minus 1 squared plus 1 equals to x. Next, we get f inverse x minus 1 equals to plus minus third of x minus 1. Finally we will get f inverse of x equals to 1 plus minus third of x minus 1. Now we have two different domains. First is from negative infinity, 2, and including 1. Second, is from, and including 1, to infinity. We also have two different inverses, that is 1 plus and minus third of x minus 1. So how do we know which domain is for which inverse? To determine this, we have to observe the restricted domain. We start with the first restricted domain. As we know, the domain of a function is the same as the range of its inverse, because the range of the inverse is, from 1 and including, to infinity. It can also be written as f inverse of x is greater than or equal to 1. We also know that f inverse x is either 1 plus third of x minus 1 or 1 minus third of x minus 1. Considering that f inverse x is greater than or equal to 1, we have to choose f inverse x is equal to 1 plus third of x minus 1. So we should consider the positive sign only. Therefore, f inverse x is equal to 1 plus third of x minus 1. The second restricted domain is from negative infinity to 1, and including. The domain of f is the same as the range of the inverse, so f inverse of x can also be written as less than or equal to 1. We also know that f inverse x is either 1 plus third of x minus 1 or 1 minus third of x minus 1. Considering that f inverse x is less than or equal to 1, so here we consider the negative sign only. Therefore, f inverse of x is equal to 1 minus third of x minus 1. Now, we are going to sketch the quadratic function separately using two different restricted domains. These are how the functions should look like. Two quadratic functions with two separated domains. Before sketching the inverse functions, we have to sketch the line y equal to x first. Lastly, we sketch the inverse function by reflecting fx on the line y equal to x.